Hello, mic test. I think everything is working fine, but I couldn't see in the PC. But in my phone, it is working okay. Maybe it's because of some network issue. Okay. Let's start with the session. If there is any discrepancy or if you can't see the video, just comment in the chat box now, so I will know if there is any problem with the streaming. Okay, so let's start this session, students. Hi, how are you? In the previous session, we have discussed what is the topic, vector and 3D geometry. We have been seeing vectors, and in that what we have discussed, what is a vector, types of vector, and addition law of vector, that is triangle as well as parallelogram law of addition, and we have solved some few problems related to basic problems regarding additions of vectors. And then we have also solved some problems regarding how to find unit vector, what is a parallel vector, collinear vectors, and like and unlike vectors. These are all types of vector. And then we have seen what is a dot product or scalar product, right? In this session, we will start with what is vector product or cross product. Yes, I hope it is clear up to dot product for everyone. So we will start with cross product from this session. What is a cross product? Cross product is defined as A cross B, A vector cross B vector, and its formula is given by modulus A modulus B sin theta into n cap. And what is this n cap? N cap is nothing but the unit vector in the direction that is perpendicular to both A and B. You can see from this figure, A vector and B vector are two vectors acting in this direction, means this n cap is a vector which is perpendicular to the plane containing both A and B. That means it is a vector which is perpendicular to, when we talk about plane containing A and B, that means it is obviously perpendicular to both A and B vector, right? So this is what cross product is. A cross B is defined as modulus A modulus B sin theta into n cap. And this is also given by, if you know the components of these vectors, that is ijk components, corresponding components of A and B vector, then we can write this vector as determinant of ijk and ax, ay, az, bx, by, bz, where ax, ay, az are corresponding components of A vector in x, y and z direction. Similarly for B vector. I hope this is clear. With examples you will be better able to understand this concept. Now we will start with properties of cross product. Again, just like how we discussed in dot product, what is cross product? A cross B, that is, we have seen in this slide, previous slide, it is determinant. Cross product is nothing but determinant, and once we find this determinant, we will get some vector in terms of ijk. Obviously it is a cross product, or it is also called vector product, as the output of this is vector, right? So what is a vector product? Output is vector and it is given by determinant of this value. And what is the first property? A cross B. How do we write A cross B? A vector is written in second row, B vector components are written in third row. Now what will be B cross A? Obviously B will be in second row and A vector components in third row. And what is the property of determinant? If we interchange any row or column, then its value will get negated, magnitude will remain same, but value will get negated. So here, if we interchange B and A, that means if you write B cross A, obviously these two rows will be interchanged, that means its value will be minus of A cross B. So that is the first property. B cross A equal to minus of A cross B. That means cross product is not commutative. Next one is distribution law. Distribution over addition, just like in dot product. Here what will we get? A cross B plus C is equal to, it is distributive, so it will be A cross B plus A cross C. This is distributive property over addition. Next one, similar to dot product. L into A vector cross M into B vector, where L and M are some scalar numbers. L into A vector cross M into B vector, that is equal to, take the scalar outside. You can see from this, L into A vector means we will get LAX, LAY, LAZ. We can take a scalar outside of any row or column. So here we will take L, here we will take M. That means we can write LM into A cross B. Do you understand? That is this property. Next one is A cross B dot A. Here comes an interesting topic. Until now we have been seeing cross product and its property. Now we are combining cross product with dot product. And what is a cross product? By definition, cross product gives the value of a vector which is perpendicular to both the vectors in this. So here A cross B is a vector that is perpendicular to A as well as perpendicular to B. That means when we take cross product with dot of A cross B dot A, then this A cross B is already perpendicular to A. That means when we take dot product with angle is perpendicular, then obviously it is 0. So answer will be 0. Similarly for B vector, I hope this is clear, because A cross B is a vector. A cross B is perpendicular to both A and B. Perpendicular to both A and B vector. Then when a vector which is perpendicular to A, when it is dot product with A vector, obviously that will be modulus of A cross B, modulus of A, and cos of angle is 90, so cos 90 becomes 0. So what is the answer? It will be 0. Similarly with B vector. Now similarly, I cross I, J cross J, K cross K equal to 0. Remember, when we take dot product, when vectors are perpendicular, its answer is 0. When we take cross product, when vectors are parallel, it becomes 0. Why do we say that? Because what is the definition of cross product? A cross B is defined as modulus A vector, modulus B vector, sin theta into unit vector in the direction which is perpendicular to both A and B. Now I cross I means modulus I, what is the angle between them? Obviously when two vectors are parallel, its angle is 0, theta is 0, and what is sin 0? It is also 0, that means this value will become 0. So I cross I, J cross J, K cross K equal to 0. Similarly, when we take cross product, when vectors are perpendicular, I cross J equal to K. Here comes an interesting thing. If we replace J cross I, we will get minus K by the definition of this. Then how to choose this I cross J equal to K or minus K? How to write this? There is a simple rule, which is the rule of thumb. If this is X, Y and Z axis, that means corresponding components will be I, J and K. Now if we take right hand side and rotate the vector and thumb is moving upward, when we take a right hand system, we will take this value as positive because we are moving from x to y to z. That means this is a positive output. So I cross j will be equal to k. This direction is k vector. Now when we take j cross I, then obviously we are coming from left side, right? We are rotating from left side. This is left thumb rule. When we take left thumb rule, then answer should become negative. So j cross I will become minus of k. Minus k means it will be in the direction which is below this. I hope this is clear, right? So this is the next property. Now we will see some questions. If a vector is equal to 4i minus j plus k and b vector is equal to 2i minus 2j plus k, then find a vector, unit vector along the direction of a cross b. Okay, again simple question. Find the unit vector along the vector a cross b. First we need to know what is a cross b. How to find a cross b? If we find a cross b, when we know a and b vector, then obviously unit vector we already know how to calculate. What is a cross b? It is defined as determinant of ijk. And what is a vector? 4. Write the corresponding components. Minus 1j plus 1k. And for b vector, 2 minus 2, 1. Now what is the value of this? Obviously I cap into minus 1 plus 2, that is plus 1. So plus 1 I cap, then minus of j cap into, we will get 4 into 1 4 minus 2, that is 2 j cap. Next one is plus k cap into, here we will get minus 8 plus 2, that is minus 6. So answer is I cap minus 2 j cap minus 6 k cap. Okay, now what do you need to find? Find the unit vector along the vector. Along the vector means in the same direction as this vector. So required answer is a cross b. Let's take this vector as c vector. Then we will get, we need to find c cap, which is defined as c vector by modulus c vector, c vector by modulus of c vector. Modulus c vector is square root of 1 square plus 2 square plus 6 square. That is defined as, that is a 641. So 1 by root 41 of I cap minus 2 j cap minus 6 k cap. Right, this is our required answer. One by root 41 of I cap minus 2 j cap minus 6 k cap. Either you can multiply or just leave it as it is, just like how we did. Right, so that is our required answer. Next question is, if a cross b whole square plus a dot b modulus whole square equal to 400 and modulus b equal to 5, find the value of modulus a. Okay, again easy question. What do we need to do, students? First understand the question, what is asked and what is given. We need to find modulus a. Here we got a cross b and a dot b values. Addition. We have been given a condition and we also know modulus b. That means we can use the basic definition first. What is the definition here? Modulus a cross b is given by, modulus a cross b is given by mod a mod b sin theta into n cap total modulus. Obviously mod sin theta will be sin theta itself, because sin theta is a positive term between 0 to 180. Sin theta is positive, And what is modulus n cap? That is 1 because it is a unit vector. So modulus A cross B value will be mod A mod B sin theta. Similarly, what is modulus of A dot B? A dot B will be modulus A vector modulus B vector cos theta. And this value should be positive. So the answer should be positive here. Okay. Now what is given? Modulus A cross B whole square plus A dot B whole square equal to 400, which means by using this condition we get A cross B whole square will be A square B square sin square theta plus again A square B square cos square theta A square B square cos square theta equal to 400. A square B square is common, so this is A square B square into sin square theta plus cos square theta. Sin square theta plus cos square theta equal to 400, where sin square theta plus cos square theta is 1. So that means A square into what is B square? B square is 25 equal to 400. Okay sir. Now what is A square? 25 4s are 100. We have to multiply that again 4 times. So it will be 16, which means modulus A vector is equal to square root of 16, which is 4. So what is the answer? Modulus A vector equal to 4. Clear now students? Easy questions. So what is the answer? Modulus A vector is equal to 4. Next question. If A vector is equal to and A dot B is given, A cross B is given, find modulus of B vector. Okay. We know A vector, but we don't know B vector. Here they have given A dot B and A cross B value. As we don't know B vector, what we can do is assume B vector as some vector, random x, y, z. So what do you need to do for solving such problems? First step is to assume B vector. Anyways, we need to find modulus of B vector. So if we can find B vector, obviously we can find modulus also. So what is B vector? Let B vector is equal to, let's take it as xi cap plus yj cap plus zk cap. Okay sir. Next what we need to do? A dot B equal to 1. A dot B equal to 1, which means we have to dot this I plus j plus k with this vector. That means I plus j plus k dot xi plus yj plus zk equal to 1. Now how to find this value? Obviously dot for dot product, multiply the corresponding components and add, which means we will get x plus y plus z equal to 1. This is our first relation. Next what is given? A cross B is equal to j minus k. Okay. Now what is A cross B? A cross B is defined as ijk, what is A vector? 1 1 1 1 1 1. And what is B vector? B is x y z. This value is equal to j vector minus k vector, j cap minus k cap. Okay, which means here we will get z minus y into I cap, z minus y into I cap, then minus of j cap into z minus x. That means we will get x minus z into j cap. Next plus k cap into y minus x into k cap. This is equal to j cap minus k cap. Now compare the corresponding components. That means we will get z minus y. Here we don't have any I cap term, so this will be xz equal to y For next relation, x minus z is equal to 1. Next relation is x minus z is equal to 1, and the next relation is y minus x equal to minus 1. Y minus x equal to minus 1. Okay, sir. Now try to solve this using all these relations. Here we got x plus y plus z is equal to 1, x equal to z, sorry, y is equal to z, and x minus z is equal to 1, y minus x equal to minus 1. Okay. Now if we replace z by y as y is equal to z, then we get, here we can replace z is equal to y. What are the relations we get? Z minus x minus z is equal to 1, and here y is nothing but z, z minus x equal to minus 1 obviously, and z is equal to y, and we also got x plus y plus z is equal to 1. So we can use this relation, x minus z is equal to 1, and from this relation we can write x plus this y is equal to z, that means we can write x plus 2z equal to 1, x plus 2z equal to 1. Correct or not? As y is equal to z, since y is equal to z. Okay, now solve these two equations. Obviously when we subtract these two, z will become 0, z is equal to 0. When z is equal to 0, z is equal to y means y is also 0. And what is the value of x? X equal to 1. X equal to 1. So what is actually b vector? B vector is x into I cap, 1 into I cap, plus y into j cap, that is 0, plus z into k cap, that is also 0. Now what do we need to find? Modulus of b vector. And what is modulus b vector? That is equal to modulus I cap, which is 1. Finished, as it is unit vector. Easy question, students. Right? So what is the answer? 1. And how to solve this? As we don't know this vector b vector and we have been given conditions, first is to understand and see how to approach this question. We already have a cap, a vector, and we don't know b vector, but we have been given two conditions. Obviously this is one condition and this is another condition. Use these conditions to try to find what is b vector and then find the value of modulus b vector. So this is how we solve this. First we will find this a cross b as well as a dot b. Assume b vector as xi plus yj plus zk, or some other b1i plus b2j plus b3k vector. Assume this and try to solve this. Right? Next is geometrical significance of cross product. Geometrical significance of cross product. Okay, what is geometrical significance? This cross product magnitude gives the area of parallelogram. Magnitude of, that is modulus of a cross b, will give area of parallelogram formed with sides a vector and b vector. If sides are a vector and b vector, a cross b will give the magnitude of area of parallelogram. So that is nothing but modulus a cross b. And here for finding area of triangle, if we divide this, then obviously we will get these two areas will be same, and this vector is also b vector. So that means again when we take modulus of a cross b, as this is area of parallelogram, this area of triangle will be actually half of area of parallelogram. So area of triangle, when we need to calculate area of triangle, it is half of area of parallelogram. Clear now, students? Okay. So this is how we find area of parallelogram as well as area of triangle. These two are correct when we know a vector and b vector are given as sides of the parallelogram. Suppose if we know the diagonals of the parallelogram, say D1 and D2. Wait a moment. Suppose we know the diagonals of the parallelogram D1 and D2, D1 vector and D2 vector. Then what is the area of parallelogram? Area of parallelogram is given by half of modulus of D1 vector cross D2 vector. When you know the diagonal, area will be half of diagonal cross product. For the sides, it is modulus of cross product itself. So modulus of A cross B, where A and B are sides. If D1 and D2, that is diagonals, are given, then its area of parallelogram will be half of modulus of D1 cross D2. This formula is also very important. You can expect questions from these three formulas. Right, what is the geometrical significance of cross product? One is finding area of parallelogram. If you know the sides, area is given by modulus of A cross B. If you know the diagonals, then it is half of modulus of D1 cross D2, where D1 and D2 are diagonals of the parallelogram, and area of triangle will be half of area of parallelogram. Next question, find the area of parallelogram whose adjacent sides are determined by the vectors. Find the area of parallelogram whose adjacent sides are determined by the vectors A vector and B vector. Okay. What is the formula? Easy question. We have to find, when we know the sides, adjacent sides, area is given by modulus of A cross B. Area of parallelogram is given by modulus of, this is sides, so A vector cross B vector. This is our required answer. So that is given by, what is A cross B? First we have to find A cross B and then take modulus. A cross B is given by ijk. A vector is 1 minus 1 3 and B vector is 2 minus 7 1. Now what is the value of this? Minus 1 plus 21, that is plus 20 I cap, then again minus j cap into 1 minus 6, that is minus 5. So it will be minus of minus 5 is plus 5 j cap, then plus k cap into, here we will get minus 7 plus 2, that is minus 5 k cap. Now what is the area? Area required is area equal to modulus of A cross B, that is equal to square root of 20 square, that is 400, plus 5 square 25, plus again 5 square, which is 25. So required answer is square root of 450. And what is 450? That is equal to 9 into 50. So when we take root, this will be root 3 into root 50. Sorry, 3 into root 50. And what is root 50? 25 into 2. So we can write this as square root of 9 into 50. 50 can be written as 25 into 2. So required answer is, when square root of 9, that is 3, into square root of 25, which is 5. So we will get 3 into 5 is 15 root 2 square units. Clear now students? So what is the area? Area equal to 15 root 2 square units. root 2 square units. First we have to find A cross B and then take the modulus. And remember, area will always be a positive quantity. Next question, If A, B and C vectors are 3 vectors, find the area of parallelogram having diagonals A plus B and B plus C. Okay sir. Another simple question. What is given? A plus B. D1 vector, diagonal 1, let's take diagonal 1 as A plus B. A vector plus B vector. And what is A vector? This one. B vector is given by this. C vector is given by this. A plus B will be, add the corresponding components. 2i minus I, that will be minus I, sorry, plus 1i. So it will be I cap. Then minus 3j, here we don't have j term, so it will be minus 3j cap. Then plus k plus 2k cap. This is D1, that is A plus B vector. Then what do we need to find? B plus C vector. D2 vector is given by B vector plus C vector. And that is equal to, what is B plus C? Minus I. Here we don't have any I, so it will be minus I cap. Then j cap is not here in B vector, and here we have 2j cap, so plus 2j cap. Then plus k cap minus k cap will get cancelled out. So this is D2 vector. Now what is the required area? Area of parallelogram is equal to, half of modulus of D1 cross D2. D1 vector cross D2 vector. Half of modulus of D1 cross D2. Now that is equal to half of, instead of finding this, first we will find what is D1 cross D2. D1 vector cross D2 vector is given by determinant of I cap, j cap and k cap. And what is D1? 1 minus 3, 2. 1 minus 3, 2. And D2? Minus 1, 2, 0. Minus 1, 2, 0. And what is the answer for this? First term is 0, minus 4. So it will be minus 4 I cap. Minus j into 0 plus 2. So it will be minus 2 j cap. Then plus k cap into 2 minus 3, that is minus k cap. Right. So this is minus 4 now. Okay. So this is D1 cross D2. Now what is modulus of D1 cross D2? We can directly write area now. Area is equal to half of modulus of D1 cross D2, that is square root of 16 plus 4 plus 1. Correct? 16 minus 4 square is 16, minus 2 square is 4 and minus 1 square is 1. So what is the required answer? This is equal to 21 square root of 21 divided by 2 square units. Square root of 21 by 2 square units. Okay, so this is our required answer. Square root 21 by 2 square units. What do we need to do? First find A plus B as well as B plus C. These two are diagonals of the required parallelogram. So area of parallelogram will be given by half of cross product of diagonals. That is half of modulus of A plus B cross B plus C. So that is given by square root 21 by 2. Simple questions. You already know how to do this, how to find determinants and how to simplify, how to find magnitude. Okay, with this we have completed cross product. With that, vector is completed. Now we will move to 3D geometry. Vector is actually very simple topic. We already learned how to do problems in vectors. What are the topics we have discussed in vectors? We have seen what is a vector, what is the difference between scalar and vector, what are the types of vectors, and what is a dot product, its properties and problems related to dot product, what is the geometrical significance of dot product, which is nothing but projection of vector onto another vector, which is nothing but a shadow. Projection is nothing but shadow of a vector on another vector. And then what we have seen, cross product. What is cross product, definition of cross product, and what is the properties of cross product and few problems related to cross product. And what is the geometrical significance of cross product, that is finding area of parallelogram or area of triangle, right? So this is about vectors. Now we will go to 3D geometry. Before going to this topic, we need to know basic definition of two terms. One is direction cosines and direction ratios. As the name suggests, this is a direction. Now what direction means? It gives, in 2D plane geometry, we learnt about angles. In 3D, we don't talk about angles as such. Instead, we use the word direction, because vector is, a point is located in this direction. So, for example, he is east to, some Ram is east to me. That means he is in the direction of east side, which can be taken as 0 degree or 90 degree based on how we orient our coordinate system. Similarly, here, direction cosine and ratio means this gives the direction of a vector. And what is the difference between direction cosine and direction ratios? Direction cosine, as the name suggests, direction, it gives the direction. And what is the direction? Direction is given by cosines. What is cosine? That is nothing but cos theta. And then if we take cos theta, what is theta? Theta is nothing but angle. And what angle should we use? Angle is given by, suppose in 3D, let's give a take some random point P, and this be x, y and z axis. Now P vector is defined by this. Yes or no? P vector is OP vector, which is the position vector of point P. And for direction cosines, here that is given by cos alpha, cos beta and cos gamma. What is this cos alpha, beta and gamma? Alpha, beta or gamma are the angles made by this vector with the corresponding axis. So what is the angle made by this OP vector with respect to x-axis? That is given by alpha. This angle is given by alpha. And what is the angle made by this vector with respect to y-axis? That is given by beta. And what is the angle made by this vector with respect to z-axis? That is given by gamma. Right? Is that clear? So what is the alpha, beta and gamma? These are the angles made by the vector, OP vector, with respect to corresponding component axes, that is x, y and z axis. Now cos of that angle, cos alpha, cos beta and cos gamma are the direction cosines. So what is direction cosine? It gives the direction, and the direction is defined by cosine of angle, that is cos alpha, cos beta and cos gamma. And this alpha, beta and gamma correspond to corresponding components of the vector, that is I, j, k cap. So what is the relation we know from this? We also have the relation L square plus m square plus n square is equal to 1. This is very important relation, students. For solving problems related to direction, cosines and ratio, there is only one formula, that is L square plus m square plus n square equal to 1. Or we can write cos square alpha plus cos square beta plus cos square gamma equal to 1. You should remember this relation. Yes, now note it down. Cos square alpha plus cos square beta plus cos square gamma equal to 1. This is a very important property. Only one property or one formula is there for solving problems from this topic, direction cosines and direction ratios. Okay, now we have understood what is direction cosines. That means when you square and add the cosines of these angles, it should always give the value 1. That is how we can define a point. We can see if the point lies in the given plane or not. Right. So that is the one property. Next one is what is direction ratios. Direction ratios are any value that is proportional to direction cosine. For example, we can take some random example and see. We can take a vector equally inclined to axis, for example, then we will get we can take cos alpha equal to 1, cos beta cos gamma equal to 0. This is not equally inclined. We will take some random examples. Cos beta equal to cos gamma equal to 0. Obviously, cos square alpha plus cos square beta plus cos square gamma will be 1. So this type of value, this type of vector will lie in this point space. Suppose we take cos alpha equal to 1 by 2, cos beta equal to 1 by 2, cos gamma equal to 0. Now this vector will lie in the given coordinate plane or not. This point does not exist in the space. Why is that? Because cos square alpha plus cos square beta plus cos square gamma value will be cos square alpha, that is 1 by 4, plus cos square beta, that is again 1 by 4, plus cos square gamma. This will be 1 by 4 plus 1 by 4. 1 by 4 plus 1 by 4 plus 0, that is nothing but 1 by 2. So this vector does not exist. Instead of this cos gamma equal to 0, if cos gamma equal to 1 by root 2, if cos gamma equal to 1 by root 2, if we change this by, if I change this by cos gamma equal to 1 by root 2, then cos square gamma will become 1 by 2, then this value will become 1 by 2, then we have to add 1 by 2, so it will be 1. Then this vector will lie in the space. Is that clear, students? So only when this condition is satisfied, we can say this vector lies in the point, this point exists or not. Okay, that is about direction cosine. And what is direction ratio? Suppose we take a point cos gamma, cos beta, cos gamma is 1. That means we can take A vector is defined by I cap plus 0 j cap plus 0 k cap. Some random example. Obviously cos alpha is this coefficient, that is 1. Cos square alpha will be 1. Cos square beta, cos square gamma will be 0. So what we get from this? Obviously cos square alpha is 1. So this vector exists as a point. Then what we need to do? Suppose we take B vector, which can be defined as 2 cap plus 0 0. C vector equal to minus 3 I cap. Now these three vectors are actually parallel vectors, yes or no? A vector is this one, B vector is twice of A vector, so this is B vector, and C vector will be minus 3 times of this vector, so it is in opposite direction. Now these three are actually parallel vectors. That means direction remains same or in opposite direction, that is it is like vector or unlike vector, parallel vectors. Then obviously these coefficients are proportional, and this type of proportional coefficient is called direction ratio. Right, what is direction ratio? Direction ratios are numbers that are proportional to direction cosine. And what is direction cosine? It is given by the relation cos square alpha plus cos square beta plus cos square gamma equal to 1. So this relation is holding for direction cosine and any given vector that is proportional to direction cosines for corresponding component, it is direction ratio. Find that if the direction cosine of the line is 1 by a, 1 by a, 1 by a, then what is the value of a? Obviously, as I was told, only one formula exists for direction cosine. What is that? Cos square alpha plus cos square beta plus cos square gamma equal to 1. And what is given here? Cos alpha equal to cos beta is equal to cos gamma is equal to 1 by a. That means we know the relation cos square alpha plus cos square beta plus cos square gamma equal to 1. So here we will get cos square alpha is 1 by a square plus 1 by a square plus 1 by a square, that is 3 by a square equal to 1. 3 by a square equal to 1 means a square is equal to 3. And what is the value of a? A is equal to plus or minus root 3. So this is our required answer. What is the option? Option D. A is equal to plus or minus root 3. Next question. If a line makes angles alpha, beta and gamma with the positive direction of coordinate axis, if a line makes angles alpha, beta, gamma with positive direction of coordinate axis, then write the value of sin square alpha plus sin square beta plus sin square gamma. Okay. What is the relation we know? Cos square gamma, cos square alpha plus cos square beta plus cos square gamma equal to 1. And from this we need to find sin square alpha, sin square beta, sin square gamma. What is cos square alpha? That is 1 minus sin square alpha. Since sin square alpha plus sin square beta, cos square alpha, my bad, yes, sin square alpha plus cos square alpha equal to 1. That means we can write cos square alpha as 1 minus sin square alpha. Similarly, we can write this cos square beta as 1 minus sin square beta plus 1 minus sin square gamma. Sin square gamma equal to 1. Next, what we can do? Take this sin square alpha, beta, gamma to the other side and bring 1 to this side. Then we will get sin square alpha plus sin square beta plus sin square gamma. Sin square alpha plus sin square beta plus sin square gamma equal to, here we will get this 1 will come this side, here we get 3 minus 1, that is 2. So what is the required answer? 2. Required answer is 2. Next question. Again, these are all simple questions. We just have only one formula for finding direction ratios and cosines. Always remember this formula. You can solve any question. You can expect 1 more question as well as 2 more question from this topic, direction, cosines as well as ratios, right? So this is very easy topic, students. Don't miss out. Next question is, if a line makes an angle alpha, beta and gamma with the positive direction of coordinate axis, okay, write the value of sin square alpha plus, this is what we did now, no? Sin square alpha plus sin square beta plus sin square gamma equal to 2. Next question. If a line makes angle alpha, beta, gamma with the coordinate axis, find the value of cos 2 alpha plus cos 2 beta plus cos 2 gamma. Again, it is same as previous question. What is cos 2 gamma plus cos 2 alpha? cos 2 alpha plus cos 2 beta plus cos 2 gamma. This value is given by, what is cos 2 alpha? 2 cos square alpha minus 1. Cos 2 theta is 2 cos square theta minus 1. So we can write this as 2 cos square alpha minus 1. What is cos 2 beta? Similarly, we can write this as 2 cos square beta minus 1 plus again 2 cos square gamma minus 1, 2 cos square gamma minus 1. Now this is equal to, we can take 2 common from these terms, that will be 2 times of cos square alpha plus cos square beta plus cos square gamma, cos square alpha plus cos square beta plus cos square gamma minus 3, minus 1 minus 1 minus 1 minus 3. So this is equal to 2 into this value is 1 minus 3. So answer is minus 1. So what is the required answer? Minus 1. Clear now students? Easy questions. Just use the only condition, that is cos square alpha plus cos square beta plus cos square gamma equal to 1. You can also do this question in reverse. Write the relation cos square alpha, cos square beta, cos square gamma addition equal to 1, and from that try to bring cos 2 alpha, cos 2 beta, cos 2 gamma. Anyways, answer will be same. Both are okay. These are all 2 more questions. So what is the answer? It is minus 1. Cos square alpha is 1 plus cos 2 alpha by 2. Similarly, you can replace from this relation given condition, you can try to bring the question. That is one way. Or from the question, try to bring the condition and apply the value. That is another way to solve this question. Answer will be same. It is minus 1. Next question is, distance of the point PQR from y-axis is. Okay, when we talk about distance, remember in coordinate geometry in previous class itself you have learned, when we talk about distance, it is always the shortest distance, because y-axis is actually a line and this is a point. What is the distance between a point and a line? Let's assume this is y-axis. This is y-axis and point is here. Let's take this axis as y-axis and point is PQR. From this point we can take any point in y-axis and find distance. Obviously answer will be different. When we talk about distance, it is always shortest distance, and shortest distance will always be perpendicular distance. So what we need to do, draw a perpendicular. Foot of perpendicular on y-axis will be the point. What is the point for foot of perpendicular? Obviously in y-axis x and z coordinate will become 0. X and z coordinate will become 0. And what about y coordinate? As we are drawing a perpendicular from here, obviously this point will be Q. Yes or no? Now we have to find distance between 2 points. Question is as simple as that. Distance of point from y-axis. That will be distance between 2 points. So what is the answer? Distance equal to square root of x2 minus x1 whole square p square plus y2 minus y1 whole square, that is 0, plus z2 minus z1 whole square. So what is the answer? Root of p square plus r square. Option D. Simple questions. Foot of perpendicular is drawn, that will be point 0, Q, 0, and from that find the distance between 2 points. This is standard procedure. You can directly remember these results. You don't even need to draw diagrams or anything. You can directly solve. These are all 1 mark questions. Find a vector r vector equally inclined to 3 axes and whose magnitude is given by 3 root 3. Vector r vector equally inclined to 3 axes whose magnitude is given by 3 root 3 units. Okay. One minute. find a vector that is equally inclined to 3 axes. That means what is the value? We already solved one question similar to that. Equally inclined means we know the relation. Find the axis first direction. Cos square alpha plus cos square beta plus cos square gamma equal to 1, and as the vector is equally inclined, that means alpha equal to beta equal to gamma. Since vectors are equally inclined, that means we will get 3 times of cos square alpha equal to 1. That means cos square alpha is 1 by 3, or cos alpha equal to plus or minus 1 by root 3. Okay, now what do we need to do? Magnitude is 3 root 3. Obviously this is direction cosine, so that means direction cosine is given by vector 1 by root 3 times of plus or minus equally inclined, that is I cap plus j cap plus k cap, I cap plus j cap plus k cap. Now this vector is equally inclined to axis. Now what is the required vector? Find a vector r vector. What is the magnitude of r vector? 3 root 3. And this vector, remember always when we substitute direction cosine, the vector will always be a unit vector. So here the required answer is 3 root 3 by root 3 plus or minus I cap plus j cap plus k cap. Okay, root 3 will get cancelled and we will get plus or minus 3 times of I plus j plus k. That will be the required answer. So what is the first thing we need to do? Substitute cos alpha equal to cos beta equal to cos gamma is same. That means we will get 3 cos square alpha equal to 1, or cos square alpha equal to 1 by 3, or cos alpha is plus or minus 1 by root 3. Same for cos beta and gamma. So the vector required unit vector is given by plus or minus 1 by root 3 times of I plus j plus k. And what is the required vector? R vector is given by, we have magnitude of this vector is 3 root 3, and this vector is also equally inclined to the axis. We have found the unit vector equally inclined to the axis in the first step. On the next step, multiply by magnitude. Then that will be the required vector. Easy questions. And that will be given by 3 root 3, and root 3 will get cancelled. So we will get 3 times of I plus j plus k plus or minus. Next is equation of line. We'll start this topic from the next session, students. And remember, always keep learning and keep growing. Success is yours line by line. Endigu endendigu namma tapasya.